Here is EI Lesson 11, Day 2. You may ask, what happened to Lesson 10 or Lesson 11, Day 1? Answer, they were eaten by an Androck, if you happen to know what that is. Dr. Seuss does. Anyway, for this guy, you're basically just solving all of these problems. These are fairly simple problems. I could really chew through these rather quickly. To make it even a little bit easier, if you scroll down here, scroll down or turn the page in your case, you have these keys, and you are able to enter the numbers for each of these little slots, or you could cut them out and glue them in. I suppose that would take longer. And you'll say, okay, this is the right number for each of the slots above. And that way you'll know which one is which, and you can get your answers correct. It also turns out, if you really get lost, I included the key for this one. So you can take a look at each of the simplified radicals and decimal approximations and which ones are correct. I strongly suggest that you do this on your own and do not use the key except when you are done. Don't use the key after every single problem to check yourself. Try to get it all done as well as you can and then use the key to check. This is a more time-efficient method of accomplishing your homework. I won't go over very many of these, just I'll pick a few and go through them. So this one right here, let's look at x squared equals 5 over 18. In order to answer this, you will simply square root both sides. So we'll get positive or minus root 5 over 18. Which really isn't that bad. If we can find positive or minus root 5 over 18, surprise, it's not here. Why is that, Mr. Watson? Why is that not showing up? Now let me tell you why. It's because somebody decided a while back that it's not okay to have radicals in non-simple form. And it turns out root 5 over root 18 can be simplified. And I'll show you how. Root 5 over root 18, by the way, is the same as root 5 over 18. Just to make sure that we have that on the same page there. Oops. There we go. Went one too far. All right. It turns out if a square number can go into your number inside a radical, you can simplify it. Remind you what a square number is. We come up here to the square number chart, wherever the world that went. There it is. Square numbers, 4, 9, 16, 25, 36, 49, and so on. Numbers that are squares of integers. Those are square numbers. Back down to our lesson here. Okay, so what square number goes into 5? Well, none of them. What square number goes into 18? Well, 9 does. Okay, so it turns out that this is equal to the square root of 5 over the square root of 9 times 2, because 9 times 2 is 18, right? Fancy stuff. When a radical is composed of two factors, or two numbers being multiplied together, you can actually take the radical of those two numbers separately. Radical meaning root, like this symbol right here, that's a radical. So we can rewrite this actually as, I'll rewrite it on the next line here. Square root of 5 over, what is the square root of 9? Well, it's just 3. This is the square root of 5 over 3 root 2. And we go back down here and we'll find that that's still not there. Why is that, Mr. Watson? Why? And my answer is because somebody decided that not only does it have to be simplified, but you also have to do this weird process called rationalizing the denominator. I actually strongly disagree with rationalizing the denominator. It's not useful like it used to be. When we had no calculators and had to look up radicals in tables, it was very useful. We don't do that anymore. So rationalizing denominators is a silly, outdated practice. I disagree with it. However, there are times when it is useful, so it's a skill that you will learn. In this case, you have to get rid of root 2 on the bottom of a fraction. How do we get rid of a root? Answer, multiply by itself. Root 2 times root 2 turns into 2, and the roots are gone. Rationalizing the denominator means that we are getting rid of the root in the denominator. So we need to get rid of that root 2 by multiplying the top and bottom by root 2. Oh, we can do that because root 2 over root 2 is a fancy version of 1. Now we get root 5 root 2, which is root 10. If you need to see that, I'll show you. Root 5 times root 2. Remember that two radicals together can be separated. If that's the case, they can also be put back together if they're being multiplied together. So this is root 10 over 3 times 2, which is root 10 over 6. That one does show up. And don't forget, since we square rooted, we have a plus or minus. Root 10 over 6, that's S11. Woo! That was a lot of work just to get that silly little answer. And that is why I think that rationalizing the denominator is a silly practice. We could have got the same thing without rationalizing the denominator. Right here. Much less work. But it's okay. That's what's expected of you, and you will see this over and over again on many different math tests and in many different math classes. So it's something you need to at least be familiar with this year, if not know how to do. Rationalize the denominator as well as to simplify radicals. I will give a general form if you'd like to take some notes on that now that we've done an example. And I'll do that over here. Okay, so to simplify radicals, a radical can be written as root A times root B, which means so that if A or B are square numbers, squares of integers, dyslexia, darn it, I've been doing so good. Radical A B can be simplified. And if we write that in math terms, then it would be square root of A squared B, which is the square root of A squared times the square root of B, which is A B. Pretty fancy, isn't it? Try to take this and move it down a little bit. Oh, we missed some of the trappings. Oh, man. All right. Anyway, I think you get the idea for simplification. To rationalize denominators, you simply multiply by the radical over itself, like this. I will not write this down as formal notes, but you can take notes on that yourself. This page is a major pain because of rationalizing and simplifying radicals. Once again, I don't agree with that, so if you want to leave your answers not rationalized, you may. However, I want you to practice at least twice on rationalizing denominators as well as simplifying when that's necessary, and it does happen more than once. Pretty much any of these where you have roots like this, you're going to have rationalization where your roots have coefficients and simplification. So there's a lot of those. Okay, I won't go through the rest of those because you do have an answer key right here. Good luck.